forget to like and subscribe this channel.
Now let's continue with the third part of lecture 3. In this part, you are going to learn a new subtopic which is phase diagram. For the learning outcome in this video, you should be able to define phase, triple point, and critical point. Next, identify triple and critical points on the phase diagram. Then, sketch the phase diagram of water and carbon dioxide. First, let's learn what is meant by phase. Of a system are parts of it which are separated by a distinct boundary. It means that we can see clearly the boundary between each phase, such as between solid and liquid and gas. Let's look at example. If we have a mixture of ice and water, therefore we have two-phase system where we have solid phase which is ice and the liquid phase which is water. Now let's look at this example. We have a beaker of salt and water where some of the water evaporate off on top of the liquid surface. So in the bottom of the beaker we have salt. In the middle of the beaker we have salt and water. And on top of the liquid we have water vapor. So there are three phases in this beaker. Therefore, this is a three-phase system. Now let's look at this example. For the first one here, we have water and food coloring, where both liquid are miscible with each other. Therefore, this is one phase system where both substance in this beaker is in the form of liquid. But the second one here, both are liquid, but the liquid are not miscible among each other because we have oil and water. Therefore, this is a two-phase system. Heterogeneous means that the liquid is not miscible with each other. Now let's look at this example. This is one phase system where we have a mixture of gas in this container. And this one here, we have one phase. Gas in the container are miscible with each other. Now let's look at another example. For a mixture of gas, there is only one phase because gases are well mixed and we cannot see the boundary between the gases. For two liquids, where both liquids do not mix, for example, oil and water, therefore this is a two-phase system because we can see clearly the boundary between the two liquids. But for two liquids, which is well mixed with each other, for example, alcohol and water, this is only one phase system because we cannot see the boundary of the solution. So as a conclusion here, for liquids that are heterogeneous, therefore we have two-phase system, but for liquid that is homogeneous, there is only one phase. Now let's look at this example. Identify the phases of the following under normal conditions. The first one is steel, number 2 mercury, number 3 aqueous ethanol, and number 4 a saturated solution of copper sulfate stored in a closed bottle. For the first one, steel is metal, therefore the phase is solid. The second one, mercury. Mercury is metal but it is in the form of liquid. For aqueous ethanol, it is in the form of liquid. And the last one, the phases are solid, liquid and gas. Solid copper sulfate is in equilibrium with aqueous copper sulfate and water vapor. Now let's look at triple point and critical point. Triple point is the temperature and pressure at which the three phases, which is gas, liquid and solid, are in equilibrium. Vertical point is the point at which there is no boundary between the liquid phase and the gas phase. Now let's look at this phase diagram for better explanation. On the y-axis we have pressure and, and on the x-axis we have temperature. There are three phases in this phase diagram, which is solid, liquid and vapor. On the left hand upper side of the phase diagram, substances have tendency to become solid. This is because at high pressure and low temperature, the arrangement of particles of substance are close to one another. Therefore, they have tendency to become solid. Next, as we go towards the right, meaning that we increase the temperature, substance have tendency to become liquid. Because as we increase the temperature of solid, it will melt and become liquid. The arrangement of particles in this part here is further compared to solid. So we have line A, T, TB and TC. Line AT, line AT separates phase between solid and vapor. Line TB separates the phase between solid and liquid, while line TC separates the phase between liquid and vapor, meaning that along line AT, this is the sublimation point of a substance. Line TB is the melting point of the substance, while line TC is the boiling point of a substance. Now let's look at vapor. On the lower part of the phase diagram, substances have tendency to become vapor because at low pressure and high temperature, the arrangement of particles of any substance will be further from one another. Therefore, they have tendency to become vapor. This is the three regions of a single phase. So region ATB is the solid phase, region BTC is the liquid phase, and region ATC is the gas phase. Line TC is the boiling point at certain temperature and pressure. Line TB is the variation of melting point at different temperature and pressure, while line TA is the variation of sublimation point at different temperature and pressure. Now let's look at phase diagram of carbon dioxide. At 1 atm, if we read the phase diagram towards the right, firstly, carbon dioxide is in the form of solid. But as the temperature increases and reaches 195 Kelvin, carbon dioxide will turn into vapor since line AT is the sublimation point of carbon dioxide. So this is the point where carbon dioxide solid turns into carbon dioxide gas. At higher pressure, which is 5.2 atm, carbon dioxide firstly will exist as solid. But if we increase the temperature towards the right and reaches point T, so this is what we call as triple point, meaning that at this temperature and pressure, carbon dioxide will exist as solid, liquid and gas at the same time and are in equilibrium. Now let's look at the last one. When we increase the pressure to 72.9 atm, at low temperature, carbon dioxide is still a form of solid. But if we increase the temperature and it reaches this point here, so this is the point where carbon dioxide solid will turn into carbon dioxide liquid. And, this, and then as we increase the temperature, carbon dioxide will exist as liquid. And finally, at 304 Kelvin, it reaches point C. This is called as the critical point where there is no boundary between liquid and vapor state. Now let's look at the phase diagram of H2O. At 1 atm, firstly, H2O exists as solid, which is ice. If we increase the temperature to 273.15 Kelvin, ice will turn into liquid. So this is the point where ice starts to melt. Next, if we increase the temperature furthermore towards the right, this is the point where H2O in the form of liquid will turn into H2O in the form of vapor. So this is called as the boiling point of water at 1 atm. Now let's look at the triple point of water. So triple point of water exists below 1 atm. So this is the point where H2O exists as solid, liquid, and vapor in equilibrium. The difference between phase diagram of CO2 and water is the line TB, where we have negative gradient for water. This indicates that ice is less dense than water. This also means that water is easier to melt at higher pressure. And this is why the melting point of water lies towards the left.